Hello, welcome to class number 9, auxiliary views, sectioning and sectioning methods, and I'm also going to show you about polylines. All right, this is the outline of topics. These are the page numbers associated with these topics in the book, and I have a PowerPoint that I'm also going to add to this showing you about sectioning methods. Okay, so from the Web Campus site, you should have seen that you need to open up this file, AUX1, and it's on the Web Campus page. You can download it and open up that file. That's necessary to start the course, start the class with auxiliary views. With that said, I'm going to switch us over to AutoCAD. And this is the file. This is the AUX1.ewg. I'm going to do one thing in here on hopes that the dimensions and anything in purple that might possibly be hard to see, I'm going to change that over to light blue or cyan so that it's easier to see. And you'll notice up in the top-down layer menu, I'm going to click to open that, and I'm going to select on the magenta color. And I'm going to switch it to cyan, the light blue. And you don't necessarily have to do that. If you can see your magenta color, that's fine. All right. Next, what I want to do is first explain what an auxiliary view is and how we would go about creating one. Okay. So I'm going to switch back over to the PDF, and this is from our textbook. Okay. You could see back in the course topics what page that was. I don't believe I have that in here. Yes, I do, page 234. All right, so to talk about auxiliary views, we have to back up a second and be reminded about multi-views. Now, it's been a few weeks since we've done this. We've had a couple of experiences with it and hopefully begin to get comfortable with it. But when we did this in class, you might recall that we had the construction lines, right? And we had the line on the 45, and we projected things over and down, or from the right side view up and over, and it gave us this circular communication. And what that's supposed to do is to get us to understand that, let's say the right side view would be if you're standing to the right of it, looking at that surface, this is what you would see, right? And same thing, if you were above looking down, you'd see the top view. And they have to be created by projecting off of your front view vertically or horizontally or so forth. Well, an auxiliary view uses that process, but to need an auxiliary view is when you need to project a surface that would otherwise not be seen in true size and shape in its standard locations, right? So this angled surface in the top view and in the right side view is not viewed in exact size because those planes are angling away from us. And the actual evidence of that is how a circle looks, right? It looks like an oval because you're not looking straight into it. So the concept of an auxiliary view is to identify that angled surface and project off of that 90 degrees as the picture is showing, right? And the perpendicular symbol. And then that establishes a viewpoint as if you were looking straight in at that surface, thereby seeing that in exact size and shape. That's important, especially when you need to add some design features to that angled surface, and you need to see that looking straight on. All right, so in theory, it's easy. It's just creating an additional view in the multi-view, but in actuality, it's going to challenge your visualization. And that's the skill that, I'm going to assume most of you are in the early stages of evolving that skill. And that means it's going to be a bit difficult. You're going to many times produce results, the auxiliary view, and those results are going to tell your eyes that it cannot possibly look like that. Right? And thereby you'll struggle with it. But if you follow the process, it will figure itself out. All right, now just to show you this view down below, When you have multi-views like this, sometimes the auxiliary view, it's in a tight squeeze, and it's not a problem if you needed to offset it, as you see here. And when I look at this, yeah, you could keep going out that way, and this could stay in alignment, but it's not incorrect if, again, you offset it like that. And we're not going to need to do that, but just showing it. You could also call this a viewing plane line, because in actuality, the object goes beyond this surface, right? It goes beyond that surface in both directions. And you would see this surface here and that surface here, and those would be distorted. If you projected that along there, these surfaces would have to extend out to see that. Forgive my scribbliness there. So the fact that you actually would see more, but you're not showing it, then this becomes what's formally called a viewing plane, right? Or a view, and that's why they label that view AA. Not everybody does that. Obviously, in the first example, you're just seeing that. But even this, you would see beyond those edges. They would extend outward in both directions. Okay? So, one more time, and this is on page 231. And let's see, there's one more example I want to show you. And that would be, this is page, let's see if I got that. Yeah, 235. So, this is the process we're going to do here, but we're going to take it to that we're going to do the extra mile and project all edges to see what we would see in the whole object if we were standing here and looking down at it, okay? And that'll give us good practice with the process and enhance our visualization skills. Okay, so these are excellent examples to show you what we're about to need to do, okay? So with that said, I'm going to go back to the AutoCAD drawing. And in here we have our front view and our top view. Yes, we could have a right side view, but that's really not necessary for the process of creating an auxiliary view. Now, here's a drawing, and I just want you to notice that if I rest my mouse on this line, you'll notice that for some reason this line wraps all the way around. And that's formally called a polyline, and if I rest my mouse on it, you'll see it'll tell me that. And we're going to learn this in a little while, but it's a line that would just be connected on all the ends. So it's poly, meaning many. You'd have many vertices. Each time the line changes direction with with a grip there, that's called a vertex. So it's one continuous line. We don't want that because we're going to be offsetting this line parallel to itself. So we're going to have to explode that line right here. So here's your explode command right into the erase button. So select explode, and then select on that line and press enter. Okay, so now you see it's into individual lines. Now, getting back to the task at hand, creating an auxiliary view, what you first need to do is identify the surface that is angled that you need to project off of. And most of the times it's dead obvious, and same with this. I mean, this is the angled line. And we need to project off of it in that direction. So what we're going to do is take this line, and we're going to offset that, and we'll keep our standard 2-inch separation between views, and I'm not sure why this is 2 1/4, but, not an issue. So what I'm going to do is go to the offset command, and down at the command prompt, remember we have to first specify the distance, so I'm going to type in 2. And then I'm going to select this line, and I'm going to move outward and click. Now, why I do that is because now it makes it easy for me to project perpendicular off of this surface. Okay? And what I'm going to do is go to my construction process. Now, as we look back up in here, we do not see any other layers. So let's create 2 layers. We're going to eventually need something for hidden, and we need a construction layer. Okay, so I'm going to go to Layer Properties. And let's say New. Let's call the first one Construction. I'm going to hit comma, so it just immediately pops up another new layer. And then Hidden. Okay, so Construction Hidden. Now with Construction, I'm going to select on the little color box, and we want that that darker gray. If that looks too dark on screen, I'll come back and I'll set it to the lighter gray. Okay, which I believe that's formally color number 8. Okay, so construction 8, we want it to be continuous, obviously with hidden. I'm going to click on white, we'll go with our standard yellow, and I'm going to load the line type hidden. Remember the shortcut, you click on any one of these down here, hit the letter H, shoots right up to hidden, click OK, click it again, OK again, and now we're good to go now. Now we're going to start out with construction lines, so let's double click to make that our current layer. Okay, so just last glance here, hidden is yellow, hidden, construction number 8, continuous, and everything else was there. So I'm going to close this out. All right, now that construction line called ray, where it has a starting point but no ending point and allows us to easily do that on angles. So the construction commands are up in your draw panel on the word draw. So I'm going to select that, and I'm going to pick this one right in the middle here. It says ray. I'm going to click that. And I'm going to snap to the each endpoint of the angled line and then snap to the offset one. And then enter. Okay? And that guarantees me a 90-degree projection. So I'm going to repeat that. Draw, ray. I'm going to snap from here to here. Enter. And I'm good to go. Now I've established the lanes. I know on this surface and this surface here, it's going to take place within those lines. Now, the next thing I'm going to do is I need to know some dimensions because I'm going to be offsetting and I need to reproduce this shape and I don't know anything about the size of that shape. So I'm going to go back to my layer dimension, set it current, and I'm going to go to linear, and I'm just going to consider these as check dimensions. I don't necessarily want to see these in the end, but I need to see them now so I know what sizes to use. So I'm going to go 2 there. I want to know what it is from here to here. Okay, let's say from here to here. And, I mean, mathematically I could figure that out, but I'm going to just put that there for ease of knowing what it is at a glance. Okay? So I basically just violated a mechanical dimensioning rule called chaining. I linked all my tiny ones up to equal the major. But remember, these are check dimensions. They're just to help us get this auxiliary view, and then I would go back and erase them. All right, so now you're going to see this is going to go fairly quickly. I'm going to offset this in continuing it in that direction. And what you have to realize is that anything in this direction, right, or parallel to this white line, is the equivalency to this direction here. Okay, so this becomes my new depth direction, whereas in the top view, my depth direction is up and down. In the auxiliary view, it's along that way. So any one of these dimensions are going to tell me how much I need to offset it, and I'm going to project from here down and then up that way to tell me where these lines take place in space. Okay? So if you can understand that process, it's a fairly simple way to do this, but, you know, I'm leading the way here. When I throw something else at you, you know, you have to hold to that process and hope for the best. All right. So the next thing we're going to do is I'm going to offset this line 2 inches to get this back edge here. I'm going to go back to offset. Now, it should already be 2, right? It is from the last time. So I don't even need to type that in, but I do need to press enter to accept that. Then I'm going to select this line, come over and click, and then enter. Okay, so the next thing I need to do is know where these 3 lines take place. Well, I know where this one takes place. It's on that edge. And this one takes place, it's on that edge. So I really need to know where this one and this one takes place. So really, the process would be, if I projected this down, it would hit right at that intersection. And if I project this one down, it hits that intersection. And then I'm going to project that off of there on the 90-degree angle to see where it falls in place here. So I really don't need to project these down because we know they're in place. And to get the edge going from here to here, I'm going to simply copy this line and copy it on each one of these 2 intersections. Right? I'm going to go to AutoCAD Copy and select this outer one, enter, snap to there and just make copies there, and then hit enter. Okay, so I'm kind of establishing a grid or almost a matrix, if you will, on that angle, and now I'm going to be able to complete this surface fairly quickly. Okay, so I know I'm 0.50 off of this edge here, and I have two options to do that, and sometimes it won't cooperate, and I'll show you the plan B. But let's say I'm going to go back to the layer 0, which is my object line layer, and I'm going to go to my line command, and I'm going to snap to here, and I'm going to ride along this edge. Now, I'm trying to find this edge, which should be 45, and it won't let me, and I know that the culprit is my polar angle's probably not set to 45. And let's say, how do I know it's 45? Let's start from there. So I'm going to hit escape. I could throw a temporary check dimension on there, angular, and I'm going to snap to here and on the ground. Oh, my bad. I just remembered you cannot click a construction line. So what I'm going to do is draw a temporary line from here to here, and that will let me snap to it. Okay? So now I'm going to go to angular. I'm going to click here and here. Oh, that's being stubborn. Let's see. How can we outsmart this? It's being stubborn because I think it's seeing this construction line over the angled line. So, got to get nasty. I'm going to move. Sorry, I'm going to move. I'm going to window this line in, and I'm going to move it from, let's say, the midpoint here to the end point there. Okay, it's still showing that angle, and I'll be able to click that right here. So, one last time. Angular. Clicking here, and there's my 45. Okay, so we have to do all that just to figure that out. Okay, so, getting back on track, I have to check my polar angle settings down here. And I see it's on 30, so that was the culprit, putting it back on 45. Now what I'm going to do is go to my line, back to the line command, snap to this point here, and now I can ride along that edge, right? And I know I have to go 0.50, right? Why? Because right here. So I just snap to here, and I need to draw a line a ½ inch, okay? So I'm going to just hold that angle and say 0.5, enter. And then I know I'm going to go 90 degrees up to here, right? So I just follow the green line, so I hit this line, right? And that was the equivalency of just going from there to there. Now I need to go along the construction line another inch, right? And then back up to here, which would be this line, and then out till I hit the edge, okay? So along this edge, I'm going to say 1, enter, right? Then I go straight up to here, click. And then this one's easy. I just come right out and snap to the edge intersection. And then enter. Okay? Now, this is a construction line, but it's actually part of the object. So I'm going to just go to my line command and just trace over it. Enter. And then this line is way too long. There's really nothing out there, right? Just like you would see in the top view. It would be as if there was a line going all the way out to there. It's not. So I don't have to delete and redraw. I'm just going to click it, grab that grip, and bring it back to here. And then escape. Okay, so there we go. That is the actual surface, looking at it straight on. That's the true size and shape. So all of these lines are true lengths in both this direction, right, and this direction. Okay? Unlike in the top view, they are true lengths. They're true lengths in this direction. So this would be true length, this would be true length, this, and this. But anything going left to right is not in true length. Okay? This is not in true length, this, and this, because they're all on an angle. And when you're looking from above straight down to that, you're not seeing them in true length. They're on an angled plane. Now, we're not done. We're going to keep going. We're going to keep drawing the whole thing. So we've got to get this whole bottom surface in. And what we need to do is the same direction, and this is where it's going to play games with your eyes and your visualization, and you have to trust it. We're going to have to project off of all of these surfaces to get to this bottom surface. So in order for us to be helped out by that, once again, we're going to go to copy, and I'm going to copy this line to all 4 bottom edges. 1, 2, 3, 4. Okay? and I need to project off of all of that to hit those 4. Now, this can become confusing if this thing is a lot more complex with all of these construction lines here. So what you could do is you could delete these or put them in a different layer and shut them off just in case you need them again. For the sake of speed, I'm going to select those 4 and I'm going to hit delete. For your homework, I'm not going to want you to delete anything because that's the only way I can check your flow, your workflow. So for this explanation, just to keep it clear, I'm going to delete them. Now, what's going to happen here is this edge right here, if I follow that all the way down to the bottom, it's here, and it goes over to here. So this is actually going to be extended. Okay? And that's this entire vertical surface, which when you're looking from this direction is no longer vertical. It's on this extreme angle here, but that's what it would look like. Okay? So we're going to go back to the line command, back to layer 0. I'm going to snap to here, and I'm just going to keep going until I hit that line. I know it's a 1/2 inch. I say 0.5, and I go back up and connect to it. Okay? Crazy as that seems, that's that surface. Next, I have to get this surface. Now, I know that's this 1-inch area here, and I know if I follow that construction line down, it's to here. So I'm going to go to line. I'm going to connect to it from here, and I go out 1 inch. And then back up and connect to it here. So there is this whole plane is this line here and that edge there. Okay, so we're only seeing the edge of that plane in both views, but now we're seeing the whole plane right there. And then one last time up to here, I follow that one. Actually, I'm sorry, I follow this one over, right? Because if I go up there, that's this line. And I draw. I follow that till it hits the edge here, and I come out, what? 1/2 inch, so 0.5 again, and then all the way up and snap to here. Okay, so crazy as it seems, that's what you would see looking at this object from that angle down clearly onto the surface, or I should say, perpendicular to that surface. So in other words, this is all true size and shape, but now everything outside of that is not. One last thing. Hopefully you're looking at and saying, wait, we're not done yet. And that is this back corner. Okay, this back corner right here is this line at the bottom. We're looking at, from the top view here, we're looking at way up here, but it's all the way down through there. So that's where we have our hidden line. I need to switch to layer hidden. Go to line command and just basically trace this from here to here. Okay, now I'm going to go up and turn off layer construction, and there's our finished product. Okay, so thinking back what I said, it looks like it's from outer space or something, right? Like a skewed stealth bomber or something. But that is the correct auxiliary view. Now I'm going to go one step further, and this was a watch me only. I am going to literally model this thing in 3D, and then we're going to literally transform it and change our viewpoint to be that auxiliary view, and you'll see that what we're going to wind up with is this, but in 3D. Okay, so just bear with me, and I'm gonna just do this as quickly as I can. We'll be learning 3D in a few weeks, so again, just kind of sit back and watch. All right, so what I need to do is get another dimension so that I can project things. And I need to know what the total height of this is. Okay, 3.75. All right, so what I'm going to do is I need to switch my viewpoint to an isometric view. And I'm going to extrude this .75. I'm in dimension layer, so it stayed in that layer. So I'm going to put that back in layer 0. And then I need to switch back to layer 0 so it doesn't happen again. All right, now what I need to do is draw a line. So I'm going to go to the front view of this object, and I need to draw a line down at a 45 degree. And when I go back to looking at this from an angle, I'm now going to extrude this. Okay. I'm going to extrude this object through it. And I'll show you this in solid here. And then I'm going to subtract the block of this from the block of that. Okay? So there it is in 3D. Now watch this. I'm going to change my viewpoint so that I'm looking straight in at that angled surface. Alright, look familiar? And then we're seeing those other surfaces fading back there. Okay, pretty neat, right? So we're not just making up stuff. I mean, this is literally what it would look like when you position yourself to be looking straight in at that. Okay? So, that's that. And what I want to do now is advance on to the next topic. Okay? So, think about what we just did. There's some examples in the book, and the real question is, will you be able to do that on your own with a different shape, right? So, easier said than done, but you're going to have a homework assignment where you will have to do that. Okay, so let's go on to the next topic, and it's called hatching. Hatching is a big part of AutoCAD. Hatching allows you to add symbols to something. And you typically don't talk about hatching without talking about creating section views. So really they're two related topics, and what I'm going to do is integrate them both together. So on the course topic sheet, it's delineated with topic 2 hatching, topic 3 sectioning, but they really are one and the same. So let's first experience the act of hatching, and then we'll step back and integrate both topics together. So for us to experience hatching, we need to draw some construction geometry. And what I want you to do is to, with the line command, I want you to just draw me freehand, right? I'm not giving any lengths. I'm just drawing this on-purpose crooked tic-tac-toe. Right? And then I'm going to draw with the rectangle command, just by eye, and put them about the same size and location as mine. And I'm drawing a rectangle, and then a rectangle within a rectangle, and then I'm going to go to the single line text command. Right? Single line, not multi-line, single line. I'm going to click inside the bigger rectangle, and I'm guessing here, I'm going to try 0.5 in text height. I don't want it to be too small. Enter, enter. Okay, good. I'm going to have caps lock on. Let's see if it's on already. No. And I'm just going to write the word text. And then one last thing, I'm going to draw a circle. And just draw a circle inside. Okay, so draw me those two shapes, if you will. Even though there's shapes within the shape on the second one. And if you need to hit pause on the recording so that you can catch up and do that. But I'm going to keep rolling here. So what I want us to do is, and you typically would do this, anytime you create hatching, you really need to create a separate layer and put the hatching in that layer. Reasons to be discussed in a little bit. Okay, so I'm going to go to my Layer Properties Manager. I'm going to go to New, and let's just call it Section Lines, because that's what they formally are called. Let's miss that. Section Lines. And I'm going to make those green. And I'm going to make this layer curve. All right. Now, assuming you've gotten to this point, to create hatching, there is the command, and it's over in your Draw panel. Okay, it's the one in the lower right corner, Hatch. select that button, and you're going to see your entire ribbon transform. Okay? Everything with hatching is related to up in this ribbon, and really we don't have to do anything up there yet. Just bring your mouse down and put it in the center of the tic-tac-toe pattern, and after a second, you'll see it pre-displays what you're going to see before you click. Okay? So let's say this is what we want. I click, and then I hit enter. Okay, so hopefully you'll see that's not difficult. Okay? There are things that can make that a difficult or problemsome process. Number one would be is if you didn't have an enclosed boundary, even if it was the slightest bit. Now this is just watch me here because I'm going to undo this. I'm going to delete my hatching. I'm going to click one of these lines, and I'm going to make just a tiny gap in here. Let's just say I got sloppy, and I'll just keep a little opening right here. Okay. Now, sometimes when you're zoomed way out, you may not even be able to see that gap. That's the deadly thing. See, I don't even see a gap there now. But let's say I go to put hatch in there, and first clue is I'm resting my mouse and I don't see the preview of the hatch. And that could happen sometimes whether it's correct or not correct. In this scenario, I'm like, oh, shouldn't I see that? And now when I click, I get this dreaded message. A closed boundary cannot be determined. And this was kind to me. It shows me, if you had a huge drawing, you would see all these red dots in a tiny area and say, oh, that's where my problem is. Right? I'm going to say close, and then I'm going to just click, I'm going to hit escape, click on this line, and drag that out. Now I know I have an enclosed boundary, and now when I do the hatch, all this red line stuff disappears. Okay? I click here, click, enter, good to go. Okay, so that's one thing that can mess you up. The other thing is the scale of the drawing. So the hatch is another category of a command where you have to be concerned with the scale. Remember, when we did text heights, we went into that architectural drawing and we had to see what scale does for that. And when we did limits and when we did dimension style. So this is yet another category where you have to match the scale of the drawing in the scale of the hatch. All right, more on that to come. Okay, so I'm going to take a step back here and let's get a little crash course on sectioning and this whole process. So I have a little PowerPoint here. And why would you section? Well, sectioning is a big part of many drawings, whether you're a mechanical person, a civil person, an architectural, construction, you're always going to need to do analysis or to cut things open. Now, you guys as engineers, this is going to be part of your process of improving or analyzing problems. You need to sometimes cut things open and get down to the root of something. All right, so when you create a section view, this just shows us the very basic three-dimensional process. That line in the middle with the arrows, that is what's known as a cutting plane line. That shows you the path of the cut. And then the arrows show you the direction that you're going to look at to see the cut. And then that surface that has the cut is going to have those striped lines, or that's the actual hatch lines that we just created in green. Okay? So think of this. Whenever you cut something open, and I might have used this example before, but if not, we can all relate to this. You get a bagel, you ask for them to put on butter or whatever on it, and they have to cut that bagel in half. That cut surface is the surface where they would apply the butter, is where you would put the striping on. Okay, so just use that analogy in your head. Now, there are many different ways of communicating sectioning. So let's just take a quick look at that. Okay, so here's an example of sectioning through different types of holes. Now, mechanical people, you need to be familiar with all these types of holes. So if you were to look from left to right, spot face, drilled to depth, a drilled hole, meaning goes all the way through, a counterbore hole, you have a larger diameter that's only, much shallower, and then you have a countersink hole, where your fastener has that angled head on it. And the green view, the isometric view, once again shows you a bit of seeing that same thing in isometric viewpoint. But on a drawing, you would see it as front view, top view, and your top view has the cutting plane line with the arrows pointing up, which means you're looking into that cut surface, and your front view actually becomes transformed into that section view. Okay, so here's something in architecture. Right? You have to show when something goes into the ground, you're showing just a partial cut view of this. This would be concrete, maybe a foundation or some part of a foundation. This is known as a fill plate, and this is an anchor bolt that is secured into that. You would have rebar and so forth. Right? So this would be a detailed drawing that would show a portion of something in section. Okay, here's just a much larger version of a sectioned part of an architectural drawing, and this shows all the features from the earth all the way up to the roof and all of the pieces in between, and it would allow a contractor to understand how it's going to be built. Okay, so very important part of the process. Okay, back to a mechanical. Now, there are different types of sections. A full section is something that is cut all the way across, right down the middle, so to speak, and you're seeing from end to end, or in this case, top to bottom in section. Okay? So that's known as a full section. Here's some practical visual examples. Now we have what's called a half section. Okay? Now, one rule that goes along with all of this is typically when you have something round, you have to go right through the center of it. You would never cut on either side of the center. So that took place on this one and any other one that we'll see. All right. So this goes, in through at 3 o'clock to the center and exits out at 6 o'clock. And the arrow says that you're looking in this direction, right? So you're only seeing the right half in section. The left half would remain its standard orthographic view or multi-view result. And then here's again, from the top view showing how that's been cut, and the front view looking into the cut surface. By the way, I don't know if you can hear in the background, I have some dogs that love to bark at the dog at the fence, so I apologize for the background noise. All right, so next we have a broken out section. This is common if you don't want to go through the whole mechanics of showing a cutting plane line in one view and the results in another view. You can simply just tear it away, and that is done by drawing a line that looks freestyle on purpose. All right, think of that. You just blast out a piece of it so that you can reveal what's happening on the inside. Now that leads to another thing. Why are we creating section views? Well, you hopefully remember from our dimensioning rules that you cannot dimension to a hidden line. So now, if we encounter that situation, we can just break it open and create a section view to reveal the interior parts. That's the one big reason, is for the sake of revealing interior parts so that we can dimension. The next reason would be because it's easier to understand what's happening when you cut it open. So for clarity. Okay? So for clarity. All right. So here's a broken out section. Let's go to the next one. And here's what's called revolved sections. This is common when you have cross sections that vary in size and shape. So what you're literally doing here is you're cutting an infinitely thin slice and you're flipping it 90 degrees to see what that looks like right in place. And that's called a revolved section. And the next would be what's called removed section. Now, a removed section is exactly what a revolved section is, with one exception. Instead of having it right in place here, and if it's big, it's going to start interfering with adjacent pieces. They show the cut plane where it's cutting through, and then they remove that, and they put it off to the side. When you do that, you have to have a labeling system. So this would be cutting plane A, and this would be cutting plane B, or section AA, section BB. And then you would label that underneath the removed results. Okay, so you may have seen drawings like that, and that's a common practice. Okay, next type of section, offset. This is another very common one. Remember, you have to go through the center of anything round. So in this case, you can't get everything, and you just have to come to grips with that. So when I change the direction or I offset the direction of my cut plane, I have to do that halfway between the features, and I must do that in 90-degree bends, right? I'm doing that perpendicular symbol thing, okay? So I would never do that and go on an angle, let's say from here down to here, and continue. It always has to be halfway between the features, feature being this rounded rectangle, and this circle. So you're halfway between the features where you would change your 90-degree bends. And then what's interesting here is your front view. You would think that right along this edge you would see a line because this whole surface here would be closer to you and this surface here would be further back. But that would make things more complex. So your sectioned result is always drawn as if all of this is moved along the same surface. It's as if it's like this, right? And my hole is going right through it there, okay? So this is drawn as if it's like that. But all we have to do is look in the top view to know it's not. Okay, so those are all rules and conventions. Okay, using the hatch command, right? So we would create our section view, and then we would have to add our striped lines to it. So notice the striped lines don't go into the hole because anything inside here is not on that surface. Remember, when you're buttering the bagel, you know, that's where the striped lines go, but the striped lines would not go on any surface behind or further back. Okay? So that's an important visualization that you have to keep track of. And they're always at a 45. You can change the direction to going another 45, and you can even change to a different angle, maybe 60 or 30, but you're not going to vary. You know, there's no reason to vary beyond those three angles, but your first choice is 45. All right, here's an example, front view, top view, and right side view. The front view is showing a cut plane going right down the middle. The right side view is the results of that cut. And here's an isometric view just to help you visualize what this thing looks like in 3D. Okay? So there's a practical example of putting multi-view with a section view and you know, the results of that. Okay, so that concludes the PowerPoints for sectioning. I'm going to stop the video here, and I don't want this to be too long. The file sizes become big and unwieldy. So this is part one. I'm going to stop the video and restart it at part two, and we'll continue now with more details of hatching with our drawing, and then we'll finish up with polylines. Okay, so end of part one.